Hi, this video is just going to give some reasoning behind these values that you need to learn for sine and cosine at 30 degrees, 45 degrees and 60-degree angles. And I do appreciate, with so much to learn in a short time, if you're doing GCSE over a year, the background is not always, you don't have the time to sort of take in all the background. But this may be useful if you want to understand where these values come from. Okay, so let's have a look. I've got a page in front of us of those values at 30, 45 and 60. So we're going to explore this a bit. Starting with our right angled triangle, hopefully you're all familiar with the fact that sine, the ratio of the angle, is opposite over hypotenuse. So if we're looking at this angle theta, then sine would be got from the opposite over the hypotenuse, and cosine would use the adjacent over the hypotenuse. So what I've written underneath is, when are they equal? Well, in order for those two fractions to be equal, the hypotenuse they share anyway, so the denominator is going to be the same. We'd have to make the numerators equal. So both this side and this side would need to be equal. And so underneath I've created a triangle where the adjacent side is 1, the opposite side is 1. And we're looking at this angle here, angle theta. Now, what would this angle be equal to? Well, if this is the same as this, we've got an isosceles right angled triangle, which means that the two angles here would also be equal and would be 45 degrees. 45 degrees. Okay. So we should already be seeing that sine 45 is equal to cosine 45. But now let's take it a step further and find out what that value is. So if we've got this side is 1 and this side is 1, can we work out the hypotenuse? Let's just label this up. So that's our opposite, that's our adjacent, and this is our hypotenuse. So we can use Pythagoras' theorem to say 1 squared plus 1 squared equals c squared. Well, 1 squared is just 1, 1 squared is just 1, so we get 2 equals c squared. So I'm going to write it the other way around, c equals root 2. Let's put that in. So therefore, sine 45 is equal to cosine 45, and that is equal to 1 over root 2. Now, as we know, we don't like to leave a denominator in surd form, so we'd have to multiply by root 2, which would give us root 2 over 2. And that, if we want to double check it, look, it's already up there. Cosine of 45 equals root 2 over 2. Let's try sine 45 is also root 2 over 2. And that is how we could show it. Okay, good. So now let's move on and have a look. I'm going to clear this and show it from the beginning. Let's have a look at 30 and 60. And to do this, I'm going to start with an equilateral triangle. And I'm going to label this up with sides of 2. And of course, we know what the angles would be because it's equilateral. Every angle is going to be 60 degrees. And then what I'm going to do is create a right angle triangle by drawing a line down there, cutting that in half. So now we have a right angle here. We've got 30-degree angle in there because we've halved it. And of course, this is now going to be 1. Let's label it up with our opposite, hypotenuse, and adjacent. And of course, sine 60 is going to be opposite over adjacent, and cosine of 60 is going to, start that again. Sine 60 is opposite over hypotenuse, and cosine 60 is adjacent over hypotenuse. We've got the hypotenuse, we've got the adjacent. Let's work out what that opposite would be. So let's do a squared plus b squared equals c squared. And in this, we know our adjacent is 1. We don't know what b is, and we know that the hypotenuse is c squared, 2 squared. There we go. So b, I'm going to jump a bit. B is going to be equal to the square root of 4 minus 1. Did I do that too fast? Let's do it, slow it down a bit. So I can say b squared equals 2 squared minus 1 squared. B squared would equal 4 minus 1. B equals root 3. Okay. So there we have our 3 values. I'm going to get rid of this. And now we can write out our values. So sine 60 is the opposite over the hypotenuse. And cosine of 60 is the adjacent over the hypotenuse. So we've now got our values for sine 60 as root 3 over 2 and cosine 60 as 1/2. We're now going to jump to this angle up here, because here we've got 30 degrees. So let's see, we've got sine 30 would be opposite over hypotenuse. Let's change those up now. Because as we've moved the angle, we've also changed the positioning. So if we're looking at this angle, this would become opposite, this would become adjacent, and this, of course, remains the hypotenuse. So sine 30, opposite over hypotenuse is 1/2, and cosine of 30, you may have predicted, you may not, would be adjacent over hypotenuse, which is root 3 over 2. So they've swapped positions. And that is just a bit of background to explain why we have those values. I hope it's been helpful.